All right, let's get into it. Today we are going deep under the hood of the modern internet to talk about something called microservices. This is pretty much the hidden architecture that lets giants like Netflix and Amazon do what they do at a scale that's just mind-boggling.
So, let's kick things off with a question for you. What do Amazon, Netflix, and Uber really have in common? I mean, sure, they're all household names, but the real answer, it lies deep in their technical DNA. It's all about how they're built to handle millions, even billions of requests all at the same time.
And that's the key, right? They are all built to scale. But to really get how they pull this off, we kind of have to rewind the clock a bit and look at the huge architectural problem that pretty much every single growing tech company eventually runs into.
And that journey takes us to the old way of building things, the monolith. You know, for a long time, this was just how you build software. But as companies got bigger and bigger, they started hitting a wall, a serious breaking point.
So what is a monolithic architecture? Well, it's pretty much exactly what it sounds like. One single, giant, unified unit. All the code for an entire application. I'm talking user profiles, payments, recommendations, the whole shebang. It's all tangled together. Think of it like a massive office building where every single department is in one giant open-plan room. Now, what happens if there's a problem in one corner? A leaky pipe, maybe? Well, it could easily flood the entire floor and bring all work to a grinding halt. That, in a nutshell, is a monolith.
And this is a perfect real-world example. Take a look at how the Netflix API evolved over time. They started, like everyone else, with a classic monolith, but as they grew, that just wasn't cutting it. So they broke it up, and different apps started talking to different services directly, which you can imagine got super messy, super fast. That led them to stage 3, where they put in a gateway to manage all that traffic. And finally, they landed where they are now with a super sophisticated federated gateway, a single, smart front door that knows exactly how to get data from all their different services. This journey just goes to show you scale forces change.
And that timeline really highlights the pain points, doesn't it? With a monolith, if just one part of your app, let's say the movie recommendation engine, suddenly gets a ton of traffic, you have to scale the entire application. A tiny bug in the billing code could literally take down the whole streaming service. And deploying updates? Oh, that was a nightmare. A small change meant a massive, high-stakes, all-hands-on-deck release for the whole system. It was slow, it was risky, and just incredibly inefficient.
So you can see why this was a problem. Out of all these challenges, a completely new way of thinking had to emerge. A new architectural style, one that was built from the ground up for the kind of scale and complexity we see on the web today.
And the difference is just night and day. On one side, you have the monolith, that one big, tangled ball of code. On the other, you have microservices, which is more like a campus of smaller, independent buildings. The whole idea is to break that one giant application apart into a collection of small, independent services that can all talk to each other. And this is what we call the microservice architectural style. So instead of that one giant office building, think of it more like a bunch of Lego blocks. Each block is its own separate service and handles a specific job. One for authenticating users, another for search, another for handling payments. The beauty is you can work on them, update them, and even swap them out completely on their own without having to knock down the entire structure.
Okay, so that's the big idea. But how does this all actually work in practice? Well, this whole style is built on a few core principles that are absolutely key to making it so powerful and resilient. Let's break those down.
It all comes back to this one simple philosophy. This is what we call the principle of single responsibility. Every single microservice has exactly one job, and it does that one job extremely well. And that intense focus is what makes them easier to build, way easier to test, and so much easier to maintain over time.
So, this philosophy gives us a few core practices. First, you build small, focused services. Step 2, and this one's critical, each service owns its own data. This is how you avoid those tangled dependencies we saw in the monolith. Third, they talk to each other using lightweight communication, like APIs. Fourth, and this is a big mindset shift, you have to design for failure. You just assume that parts of the system are going to break, and you build in resilience from the start. And finally, you wrap each service up in its own little container, using tools like Docker and Kubernetes. That makes them super easy to deploy, update, and scale independently.
But, and believe me, this is a huge but, all of this power does not come for free. When you move to microservices, you are absolutely introducing a whole new set of pretty significant challenges. It is all about the trade-offs. I just love this quote because it really gets to the very heart of engineering. There's no such thing as a right answer for everything. Choosing an architecture isn't about finding some perfect, magical solution. It's about really understanding which set of problems you are willing to live with to get a specific set of benefits.
And this table here lays out those trade-offs perfectly. On the plus side, you get amazing scalability, you get the flexibility to use different technologies for different jobs, and you get incredible resilience. But on the downside, you are now in charge of managing a very complex distributed system. This requires a ton of operational overhead and a really mature DevOps culture to pull off. You have to worry about new things like network latency, that slight delay when one part of a web page loads just before another, and keeping your data consistent across all these different services becomes a much, much harder problem to solve.
So after all that, what's the big takeaway here? Why is it so important to understand this massive architectural shift if you're building anything for the web today?
Well, this chart really says it all, doesn't it? It's a powerful visual of one of the single biggest benefits, resilience. See, in a monolith, one failure can easily bring the whole system down. But with microservices, if one service goes down, say the search function breaks, it's isolated. The rest of the application, like logging in or actually playing a video, can keep chugging along just fine. For system uptime, that's an absolute game changer.
And really, that's why this matters so much. This architectural style, this big shift away from a single, rigid block to a flexible collection of independent services. This is what makes it possible for companies like Netflix, Amazon, and Uber to operate at a scale that was just unimaginable a couple of decades ago. It's truly the engine running under the hood of the entire modern web.
But that leaves us with one last really interesting question. If microservices are so powerful, is the monolith ever the right choice? And the answer is, yeah, absolutely. As we saw with Netflix, most companies start with a monolith. It's simpler, it's faster to get up and running. The real art of system design isn't about picking one over the other, it's about knowing when your scale and your complexity demand making that jump. Something for you to think about. Thanks so much for tuning in.